All right, welcome back. You got page 3 going on here, number 10. All right. Um, Given the measure of angle AEC is 4x minus 40, BED is x plus 50. We're trying to prove here that x is equal to 30. So this is our, right, an example of our algebra proof. So first thing I'm going to do, let's solve the equation. So I'm going to go over here on the right, and I'm going to solve the equation. So 4x minus 40 is going to equal x plus 50. So remember, these two angles are equal. They're vertical angles, right? Remember, vertical angles are congruent. So I'm just going to solve. So I'm going to take x away from both sides first. So 3x minus 40 is equal to 50. I'll add the 40 to both sides. 3x is now equal to 90. I'll divide by 3. And I'll get x is equal to 30, which is what we were trying to solve. So what we need to do for our proof is really get the step that says these are equal, okay? And so remember, the vertical angles are equal. That really means that angle CEA, right, the measure of that, is going to equal the measure of angle DEB. So once I have this, okay, then I can substitute in this, and I can do my subtraction, addition, product, equality, finish with division, and we're all good to go. So that's the game plan here. So, T-chart. Statements. Reasons. Okay. Put down my number 1. Measure of angle AEC is equal to 4x minus 40. Measure of angle BED is equal to x plus 50. And that's given. Okay, so throwing in the first part, which is our geometry reason here, is the measure of angle CEA is equal to the measure of angle DEB. All right, and this was just vertical angles are equal. Now I'm going to swap out CEA for the measure, which is 4x minus 40, and then the same thing with the x plus 50 here. And so this is just substitution. Okay. And then we're going to start working on our thing. So the next line we had earlier was this 3x minus 40 is equal to 50. So this is subtraction, property of equality. Okay. Then our next line was 3x is equal to 90, which is our division, property of equality. And then, whoops, no, it was not division, that's addition. The last one, x is equal to 30, proof statement, so we know we're doing. That's the division. All right. All right. So there you go. There's that lovely proof right there. Okay, number 11 is a construction question. I will post a link to a video on how to do this one. But essentially for doing the bisector of angle ABC, remember the first thing we're going to do is we're going to draw a circle B. You can choose your radius. Remember, it just wants to hit this twice. So as we draw our circle around, it should make contact with side AC twice. Okay? We're going to get these 2 points right here. So we'll call them D and E, right? And we're going to basically draw 2 circles. Now, notice that I call these points D and E, so that's my reference points. I'm not going to go through the labeling on this, but just be aware that when they refer to D and E, it's where circle B intersects angle ABC, okay? We want to draw these 2 circles, and remember the radius needs to be more than half, right? It's greater than half of the line that connects between them. So any 2 points here, any 2 circles, right? and they should cross, and then we're going to do our line right down the middle. All right. And if you want to call this point F, whatever you want to do, I'm drawing line BF. If you're using letters, make sure in your reason here, or your steps, if you need them, you're introducing the letters. So if you say, like, I should have step 1.5, which is like label, right? D and E as a point square, circle B intersects angle ABC, and same thing. If I say F, right, there should be like a 2.5 here somewhere that says label F as the intersection of circles D and E, that type of thing, and then we're drawing it out. All right. Okay, perpendicular bisector of segment AC. This is the nice easy one. So you're just going to draw two circles, right? A and C, so that the radius is more than half of AC. So any circles you want, so the radius is more than half, and then we're going to do our line right down the middle. That's a terrible looking line. Well, you get the idea here, right? Well, you can't even see it. Great, you didn't even see how bad it was. All right, that's what we're looking for. Okay, then we're going to draw, all right, segment, line, ray, whatever you want to call it, that connects, right, the intersections of the two circles. And that's the game plan there, all right? Awesome.